Yo, what's up? It's your boy Mr. AC, and what I got for you guys today is going over primarily, and we are on year number, so let's go ahead and get started. All right, my AP Calculus students, let's go ahead and get started on question number 12. A very interesting but very tough problem. Now, this problem actually, y'all, is actually pretty tough, man. I ain't gonna lie with y'all. It has a lot of stuff, and you'll notice it's kind of cool if you're doing all the years with me, because you'll notice the level of difficulty, and then you'll see kind of the trends that they have. Notice how they're involving the second derivative a lot in these problems, and it's really asking you to do a lot of analysis with the second derivative and concavity. So nonetheless, let's go ahead and read the question. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. So they just tell us that this is the derivative right here. At t equals 0, when the baby first weighed, it weighs 20 grams. So we got the initial condition. We know the baby first weight was 20 grams. If b of t is the weight in birds and t is the days after its first weight, then this is the function down below. Let y equal b of t be the solution with the initial condition. Awesome. Now, part A can be a little bit tricky. We're going to try to make sense of it the best that we can. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your reasoning. Now, part A is asking you about speed, right? When they're asking for speed, they're talking about your first derivative. They're essentially talking about your, if I write PVA, your velocity. You want to compare velocities. Which one is moving faster? Now, birds gaining weight doesn't have velocity, it's just speed. That's why it's the first derivative. So hopefully that makes sense. All we have to do is take 40, plug it into B, take 70, plug it into B. So I'm gonna do that right here. All right, so I plugged these into these values, and now I want to know which one is gaining weight faster. Well, if you kind of compare the two, I plugged in the 40, I plugged in the 70. If we compare both of these, right, 100 minus 70 is 30, 100 minus 40 is 60. So if you notice, this one is going to grow faster because the value is going to be much larger than this one. Now, I don't even have to solve these out all the way. I can if I want to, right? This one here, I'm going to get 60 over 5, and then this one over here I'm going to get 30 over 5. Justification is guided with these two problems that I have right here, 60 over 50, 30 over 5. So I know obviously this one up here is going to be growing faster. So hopefully that makes sense, y'all, and then our justification is right there. Now let's go ahead and go on to part B. Part B being a little bit of a tough one because it's asking us find the second derivative, and then it says use your second derivative to explain why the graph of B cannot resemble the following graph. So I want you to understand that this following graph is giving you the original, and they're asking us to use our second derivative to determine whether or not it can be that graph. Well, one thing I want you to think about is this. What does the second derivative tell you? Concavity, concave up, concave down. So if you look here, right, there's a little portion maybe that's concave down, maybe there's a little portion here that is concave up. So let's go ahead and take our second derivative, and let's go ahead and see what we actually get when we do this. So what I'm going to do first is distribute the 1/5 across. So what I decided to do here was go ahead and distribute the 1/5 across, because I know 100 can be divided by 5. I just put it as a single fraction. I don't want to do that with this over here. I usually like to take the derivative separate from our constant. So 100 divided by 5 is 25, and then we get this right here. So now let's go ahead and take our second derivative. Well, here's the good news. If I take our second derivative, this is actually wonderful because the derivative of 25 is gone. That's 0. And we get negative 1/5 dB over dt, right? Because we're taking derivative of b with respect to t. There's no t, so it's implicit differentiation, and we get this right here. Luckily, we already know what dB over dt is. dB over dt is right here. Now, usually for me, I usually like to plug in this original because it's not, let me go ahead and put it in here. This one is not simplified down, and I can see this a lot better. So I'm going to get d2. I'm going to just write it out real quick. So what I did is I took dB dt, I plugged it in for dB dt right here. That way I have this written out. Now, obviously I could distribute this across, but all I really want to do is this real quick. Let me just write this out one last time, y'all. I know I'm running out of room here. We get negative 1 over 25, and then parentheses 100 minus b. Now, here's a couple things I want you to kind of be aware about. Is if we plug values into my second derivative, that should tell me whether something is concave up or whether something is concave down. Now, if you look on this graph from 20 to 100, notice how there is some kind of change in concavity here, right? You can see that it goes concave up and then concave down. So my goal here is to maybe disprove one of these because it tells you it shouldn't be, right? So for example, if I plug in like 25 into here and I get a positive value, then okay, I know it matches this graph. If I plug in, let's say 80, I should be concave down, right? So for example, if I plug in 80 into B, if I was to go ahead and plug in 80 into B, I get 100 minus 80, that's 20. 20 times this negative value is negative. That means it is concave down. So that kind of makes sense. It should be concave down on this interval. So that matches. So now let's go over here and let's say we plug in 25. If I plug in 25, or shoot, if I plug in 20, we don't even have to plug in 25. If I plug in 20, let's say 20, 100 minus 20 is 80. 80 times this is negative. Well, that tells me if this is negative when I plug in 20 into B, that means it should be concave down. Well, look at this region over here. It is concave up. This graph is concave up right here. So that is going to tell me now that it cannot match it. So how can I use the second derivative to explain why the graph of B cannot resemble the following graph? I'll say using my second derivative, when evaluated at 20, the second derivative is less than 0 at 20 grams, which means it should be concave down. But on the graph, it is concave up. Therefore, it cannot resemble the following graph. So hopefully that makes sense. Also, you probably just heard my dog in the background yawn. But that you're just using these values to disprove that it should not be concave up. That should take care of A and B for us right here. We can go ahead and move on to part C, but part C is very similar to the problem we did prior. So I'm going to leave that be because part C is just going to involve separation of variables. And if you check your answer key on this problem, if you check the answer key for the document, I think it has a good progression. Again, it's very similar to what we did in 2011. So hopefully you guys enjoyed. That'll take care of 2012 for us. Capiche?